Okay, good morning, everybody. It is Wednesday morning, and I am up early to do our science experiment. I have my coffee with me. So let's get started. Today we are doing deep water and surface currents. Remember, there are two types of currents. The movement of deep water currents depends on how salty the water is, its temperature, and its density. Surface currents are mainly caused by wind, which is a result of rotation of the Earth. So our first step is to measure 97 milliliters of very cold water into the graduated cylinder. So I'm going to put that right here. Still trying to get my camera up high enough so you guys can see everything. If I hold it for a second. There we go. So I have a pitcher of ice water. I'm going to fill almost to 100. That's about 97 milliliters. I wish you guys were here to confirm. And then the next step is to add enough salt until the water rises to about 100. Let's see if I bring this down. The light is terrible this time of morning. So I'm going to add some salt. I don't think you guys can see it because of the light this morning. Okay, so that water now is very saline. It has a high salinity. I just added a lot of water to it, and I need to now just observe the salty water. It is a lot sort of foggier and it's very hard to see. Okay. And now I need to add some food coloring. So it says to add blue. I only have yellow, so I'm just going to add a lot of yellow food coloring to make it kind of dark. Okay, that should be enough. It's more like an orangey color now. We're going to stir it up in a sec. Let's see. I need my lab assistant today. I am going to go and grab a spoon and a straw. Give me one sec, everyone. All right, so now I'm going to stir, stir, stir. It's hard to get something long enough to go into the cylinder. I don't know if you had that problem at home. What I might do to stir it up is pour it into this jar and then pour it back in to try to get that salt loose at the bottom of the cylinder. There we go. I think that helped. There we go. This water was very cold, and now it's very dense and high in salinity. I'm going to put it to the side. The next step is to just compare it to fresh water. So here's our fresh water. Like I said, now that we've added a lot of salt, it is very dense and saline. Okay, it's also very cold. All right, now we need to put this salty water aside because I need my cylinder to measure some salt. So I'm just going to rinse out my cylinder a little bit with some water. To pour this water into an old bucket I have sitting on the side of my classroom here. Okay, so measure 60 milliliters of salt. That's a lot of salt, everyone. Okay, that is about 60 milliliters of salt. And now I need to pour 2 liters of very warm water into this baking dish. This is why I have the baking dish sitting here. And I boiled some water this morning. So if you're going to boil water, make sure that you have help from an adult because it's very hot. Not sure if you can see the steam coming off on the camera. All right, and then it says to pour the salt from your cylinder into your baking dish. So we are making this like the ocean as well. We are giving it some salinity by adding salt. We are making it warm, I guess sort of like the tropical ocean maybe. Remember, the closer you move to the equator, the warmer the water gets. So I'm going to stir. It says stir, stir, stir until the salt is dissolved. And then it wants you to let the water sit until it is calm. I wish I had one of you here to assist me. I think in November for our class outing, we're going to have a science experiment outing. So you guys can meet me at the park and we'll do some science together. Okay, so we're gonna let that sit. See how it's, the waves are kind of moving, of course, because I was stirring it. We're gonna let that sit for a second. I'm going to have a sip of coffee. It is 8:15, which means we have class soon. I have to finish up here. Okay, so now that we've let that sit, while we sit, it says, think about how deep water currents form in the ocean. Cold, salty water near the North Pole is very dense. It sinks and then flows towards the equator, where it is heated. Then it rises, becomes less dense, and flows back to the North Pole as more cold water moves in. So what do you guys think will happen as I add the cold water to this warm water? What do you expect will happen? Will the cold water sink just as it does in the ocean? So let's see. So I have my icy cold water and I have my warm salty water. I'm going to add this to the water and see what happens. You can see the color sort of taking over. You can see it moving across the pan, sort of making a current. It moved over. If you guys were here and could see closely, the orange water is down on the bottom. It's sort of layered and the warm water is still on top. So the cold water did sink and the hot water stayed close to the surface. So it says, if your water is still, slowly pour the cold water into one end of the pan. Okay, we did that. Observe what happens. You should see the cold salt water sink and move across the bottom of the pan, creating a current. So awesome. We just created now a deep water current. Now what we're going to do is create a surface current. So remember, surface currents are caused by wind and the rotational pattern of the earth. The earth moves. So we are going to recreate that with a straw. I have a straw. It says blow gently through a straw across the surface of a pan of water. Observe the ripples that occur from your wind. These are surface currents. So let's see if I can blow hard enough. So you guys should be able to see surface currents. All right, so I hope that you guys try this at home. This was one of the simpler experiments. We created deep water currents and surface currents.